Now look at these two problems here. Notice that your exponent is a variable. It is not a number. So the rule that we have for taking the derivative, like if I gave you y equals x to the fifth, bring down the exponent, reduce the power by 1, this is only when your exponent is a number. When your exponent is a variable, you cannot use this rule. So we're going to have to do something else here. There's not another rule for this, but what we're going to do is what's called logarithmic differentiation. We're going to take the log of both sides. So we can introduce logs, and we know how to take the derivatives using logs. So what I'm going to do is I'm going to go ahead and take the log of both sides. Anything I do to one side, I can do to the other. Now, what this allows me to do is property of log says if I have an exponent, I can rewrite it by putting it in the front. So I'm going to rewrite it like this. Bring the x down, natural log of x. So this eliminates that exponent that's a variable now. Now, what I'm looking for is I still want to get y prime, so I'm going to go ahead and take the derivative. Okay, now we are doing implicit differentiation. So the derivative of natural log of y is, remember, 1 over y. Remember, the derivative of y is not 1. Chain rule times dy dx, or y prime, equals. On the right side, you have two factors that have a variable, x and natural log of x. So you have to use the product rule. So the derivative of the first is 1 times the second plus the derivative of the second is 1 over x times x. Now you still need to solve for dy dx. When I ask you for the derivative, you have to get y prime by itself. So I'm going to go ahead and I'm going to simplify this to 1. I'm going to go ahead and multiply the y over, so I end up with that. But there's one more step that you can do on these problems. Well, I know what y is. Y is just the original function, x to the x, so I can replace that with x to the x. So you can get a derivative all in terms of x. Why don't you pause it, try the next one on your own, and then come back to check it. Okay, I notice my exponent is also a variable, so we're going to do logarithmic differentiation. That just means take the log of both sides. So start with this. Properties of logs allows me to bring the exponent to the front, so all of x plus 1 comes to the front, and I have this. Okay, I'm trying to find y prime, so I'm going to go ahead and take the derivative of both sides. I have 1 over y times dy dx, or y prime. I have to use the product rule here. Derivative of the first is 1 times the second, plus the derivative of the second is 1 over x times the first. Solve for y prime. And I'm just going to move that y over, and I'm going to do the substitution right away. So y is really this. So this is my answer.